Fractals in computer graphics. We often see amazingly realistic landscapes in movies and video games. Have you ever wondered how complicated scenes like mountain ranges, flowing clouds, or branching lightning are created? Surprisingly, they often begin with simple rules repeated again and again. That idea is called fractals. Fractals are structures with a property called self-similarity, where small parts resemble the whole. The same shape repeats itself at different sizes. Because of this property, computers can create nature's complex patterns using only simple rules. It is much like growing a giant tree from a single small seed. Shapes like triangles and circles, which we learn about in school, belong to Euclidean geometry. These shapes are neat and precise, made with smooth lines and exact angles. Nature, however, is different. Clouds have blurry edges, coastlines are jagged, and lightning splits in irregular ways. To describe these forms, we need fractal geometry. So, how do computers create fractals? One important tool is something called a recursive algorithm. Recursion is a way of solving problems by repeating the same process over and over. It may help to think about Russian nesting dolls, where smaller dolls are nested inside larger ones. Recursive algorithms can describe very complex structures in surprisingly simple ways. Once we create a basic rule, the computer can repeat it over and over to create increasingly complex shapes. However, as the repetition continues, the computer must use more memory, which can slow things down. One famous example of recursion is the Tower of Hanoi puzzle. If there is only one disk, it takes one move. With 2 disks, it takes 3 moves. So, how many moves are needed for 3 disks? If we try it ourselves, we discover that it takes 7 moves. When we look carefully, we can see a pattern. The solution repeats the result from the previous step twice, then adds one final move. If there are n disks, we can find the answer by doubling the number of moves needed for n-1 disks, and then adding one more move. This process of solving small problems again and again is recursion. Using this idea, computers can create complex natural scenes such as mountains, trees, and clouds. They only need to store the rules instead of every single detail, which greatly reduces the amount of data that must be stored. This is why scenes like explosions or outer space in movies can look much more realistic. However, there is an interesting challenge. Images created with perfectly regular mathematical rules can sometimes look unnatural. Why? Because nature itself is not perfectly regular. No 2 clouds are exactly the same, and no 2 trees are identical. That is why computer graphics often include small changes on purpose. When we slightly change the input values, the differences grow larger during the recursive process, creating much more natural-looking results. At this point, let us stop and think for a moment. Which feels more natural to you? Something perfectly regular, or something with a little irregularity? Perhaps the beauty of nature does not come from perfect order alone, but from the small irregularities hidden within it. And fractals are a powerful mathematical tool for describing that boundary.